Problem 9.8 has this circular or bottom half of a circle, so semicircle ditch, that fills at 2 inches per hour. The water level is going up at 2 inches per hour, and we want to know the width as a function of time. How wide is it? This W here is a function of time. All right, so as time goes on every hour, and I guess we want to know it in hours, because 2 inches per hour is not very fast. So our time will be hours, and our width will be in feet. Okay, I think we want to just do everything in feet. We could do everything in inches, but I think they give their answers in feet, and everything else is in feet. So we're going to deal with feet. So first we got to change 2 inches per hour into feet per hour. So 2 inches is 1/12 of a foot, right? So 2 inches divided by 12 inches per foot. So the foot's in the bottom of the bottom, which is the top, so that's 1/6. So 1/6 feet per hour. So now we can just use 1/6 for the rate that the water goes up. And we know we have feet, we know we have hours, and we know whatever we get will be in the right units. Our width will be in feet, and our time will be in hours. Okay, so first you got to notice that the width is the x value of our circle, right? So the x value here, actually not quite. So here's the x value, right there, right? That's the x value, and here's 0, and there's x. So the width is 2 times the x value. So I should say, so the width here is 2 times the x value as a function of time of that thing there. Okay, and the x value, let's see. Yeah, now the y value, we know what that's doing. That's going up at 1/6 foot per hour. The y value goes up at 1/6 foot per hour. So we want to know what the x value is doing, because we know what the y value is doing. Now, as always, so that's kind of the overall idea, right? So that the y value goes up at 1/6 foot per hour. What is the x value doing? Which is kind of weird because it's a circle, so it's not a very steady change, right? It's yeah. So we want to choose, as always, the center of the circle right there. Make that 0. That is the center of the circle. Make that 0, 0. Make that the origin to make our circle equation nice. So then we have x squared plus y squared equals 5 squared, which is 25, of course, because it's 5 feet. And we want to solve for x, because we know what the y value is. Okay, here's the trick. Y starts off at -5, right? It's 5 feet. Here's 0, 0. So our y value starts off at -5 and gets bigger by 1/6 feet per hour. So that's kind of tricky. So y starts off at -5 feet, and then we add 1/6 foot per hour times time, right? Times the number of hours gives us feet. Feet per hour times hours gives us feet. Yep. So this is like parametric equation for y. Starts off at -5 down here, right? Because that's 0. We add 1/6 feet every hour. So 1/6 feet times the number of hours. Okay, so that's one tricky part. So we know what y is, and now we just need to solve for x from this equation, and we know what y is, and then we should be good. So let's see. Put the y squared over here. X squared is equal to 25 minus y squared. Let's figure out what y squared is here first off. So y squared is -5 squared, which is 25, plus this squared, which is 136t squared, plus 2 times them multiplied together, which would be a minus, because that one's minus. So let's see, what's that? -10, 2 times multiplied together would be 5, 6, -10, 6. So minus 10, 6t. Yeah, that's a mess. Okay, well, now we want what x is. So x is the square root, and we want a positive number, right? We want to know what this value of x is, because our width is just, we're just going to double it to find the width. So x is the square root of 25 minus y squared. So that's minus all this stuff. But look at that. This is going to be nice. 25 minus 25 minus 136t squared plus, okay, 10 6, let's divide that in 2, that's 5/3, right? Divide that by 2, 5, divide that, yes, so plus 5/3 t, because it's all, everything's minus. So this is minus, this becomes minus, this becomes a plus. Okay, I think that's right. And it's wonderful because 25 minus 25 goes away. And now we're just left with this, which is not so wonderful looking. Let's put the 5/3 t first. So x then is equal to square root of 5/3 t minus 1/36 t squared. And the width is just 2 times x. The width is just double that, right? If this is x, the width includes this. So the width then is 2 times that. And let me see how we want to make sure we get the same answer they do, which is always nice. So let me see how they wrote it. 2 times 20. Okay, they left it as t over 6 minus 5 squared. Okay, so they did square this. They did not square this. They just left this as t over 6, right? This is the same thing as t over 6 minus 5, right? Because 1/6t is t over 6 minus 5. They just left it like that. Okay, so whatever. We've squared it out. No big deal. So this is it. So the width is equal to 2x, which is equal to 2 times the square root of 5/3 t minus 1/36 t squared. Okay, cool. Now they say look at the domain and stuff, right? Specify the domain and compute the range. So the domain is what allowable values of time are there. Well, once we get to the top, it's going to overflow. So the time after that doesn't make sense because our formula doesn't work anymore for the width, right? It overflows forever. Who knows? So we got to figure out how long it takes to overflow. Well, it's going up 1/6 foot per hour. So that means that in 6 hours, it goes up a foot. This is not very fast, is it? It takes 6 hours to go up a foot. And we have 5 feet. So 6 hours equals 1 foot. We have 5 feet, so multiply by 5. So 30 hours would be 5 feet. So our domain for t would be, let's see, it includes 0. So 0 to 30. And we can include 30 because that's when it fills up. 0 to 30. So we'll put brackets there because it includes 0, includes 30. But after 30, it overflows and the width doesn't make sense anymore. That's our domain. That's the allowable values for time. And then what else here? Okay, what is the range? What does the width go? Well, the width goes to 10 feet, right? Right here it gets 10 feet and then it overflows and everything. So it can be 0 when we start off. Just put 1 drop in, it's 0. So this is the domain, and the range would be, can go from 0 to 10. That's the range. That's how wide it can be, right? Okay, that's not so bad. Let's see, what else are we supposed to do? After how many hours will the surface of the water have a width of 6 feet? I will let you figure that out. This is our formula for the width. You plug in, you set that equal to 6. You want the width to be 6 feet. 2 times this equals 6. And you solve for t there. What time will give that to you? You might have to use a quadratic formula or something. I'm not sure if it works out nicely. So that's pretty good. Then they say give a function t f at -1 of w relating the time to the width. Okay, so the last part, you solve for t. So then you can say, okay, at what time will the width be 2 feet? At what time will the width be 3 feet? And you'll have a formula for it. You solve for t. Like you pretty much could have done, should have done here. Like they say when, for part B, they say how many hours will the surface of the water have a width of 6 feet? Basically, if you do C first, then you can just use your formula. Because really you can do that algebra twice. So what I would do is do part C first, solve for t here. T as a function of w. That's the inverse function here. And then you can plug in w equals 2, and you get an answer. That might be easier than doing b all by itself, so you're welcome to do that. But now the idea is, too, that when you do that, The domain of the new function will be this, will be the range, and the range of the new function, the time function, will be the domain of the old one. They always swap. Okay, I hope that makes sense. Again, using your circle prowess that we've developed so well, right, with putting the circle here and knowing x squared plus y squared is 5 squared. I think I'm just being really careful that the tricky part here is the y value, right? It starts at -5 and goes up 1/6 feet per hour, which means 1/6 feet per hour times the number of hours. That's the position. This is like the velocity, right? This is like the rate of change times time. The y position is the starting y position plus the rate of change times time, just like the other parametric equations we did. Okay, good. I mean, a lot of you probably hopefully got most of this on your own, but it's a little bit tricky. It's a good problem, so hopefully that straightens out for you.